7.5, last section of the unit. Now, what we have here for 1 through 3 is we have a quadrilateral, which means we're going to have 360 degrees total interior angles. We'll use that later. Now, notice we have parallel lines, and we have a transversal, which gives us alternate interior angles right here, which means angle 2, we know, is 60 degrees. Now, angle 2 and angle 1 form a straight line, which means they're a linear pair, they're supplementary, which means they add up to 180 degrees. So if we take 180 degrees minus 60, we get 120 degrees for angle 1. Now, we're going to come back to this important information right here. If we know we have 120 here, we have 60 here, and we have 90 here, that's what that symbol means. Yes, that is a 90. No, that's just a blob. Better blob. So, if we add those up and subtract from 360, we will get 90 degrees also on number 3. Alright, numbers 4 through 6. We still have a quadrilateral, we still have 360 degrees, we still have parallel lines, and we have a transversal, which means this angle and this angle, by alternate interior angles, means number 4 is 45 degrees. And 4 and 5 form a straight line, which means they are a linear pair, they are adjacent, they are supplementary, which means they add up 180 degrees. So if we subtract 45 from 180, we get 135 degrees, and we work backwards, and we're going to do the same thing to get angle 6. We know this is 45, we know this is 135, we add those two up plus the 71, and subtract from 360 degrees, we get 109 degrees. Okay, mid-segment. MN is the mid-segment. This is the mid-segment. Well, the smartboard would line up. Those are my mid-segments. Which means these points right here are midpoints. Which means that this segment is equal to that segment, this segment is equal to that segment, and so forth. We already have them marked here, but that's for a different thing. We know that these two are equal. And since those two are equal, we know this is equal. Actually, they're all the same measurements. And then again, this is equal to that, that's equal to that. That's what mid-segment means. The mid-segment connects the midpoints of the shape. Now, we just need to work on finding x and y. Well, we're doing x here first because we just marked those equal. So if the one segment's 4, x is 4. The mid-segment is also half of the parallel base there. So y is 5.5. Alright. So, n is the midpoint, which means this is 10. Because this is 10. But we also have these marks saying these two are the same, so those are 10. And since these marks are equal, that's also 10. So y is 10. And then x, this line here is double the mid-segment, so x is 24. Remember, if you need to hit pause anytime, go ahead and do so. So x is 9. We've already marked those equal. Now we have to find out y. Well, we know that this is going to be 17. Why do we know that? Because it's half of the parallel base. And then what we have is we have a right triangle, because since this line is parallel to the base, those are both 90. So that means we have a Pythagorean Theorem situation here. So I'm going to do 9. Well, I'm going to hope my board isn't going to screw up again. we're going to do 9 squared plus 17 squared to get that hypotenuse of c squared, which is what y is. So that tells me that c squared is 370. Yes, that's a 7, sorry. I square root both sides, and I get c is equal to about 19.2. So y is 19.2, or 19.24 if you round it to the 100th spot. We'll also talk a little bit here about reducing or simplifying radicals, because we're going to be doing that. Okay, show that this shape is a trapezoid. Then decide whether it is isosceles. Okay, first off, show that it's a trapezoid, we need the bases to be parallel. So that means we need this slope and this slope to be equal. So let's find the slope of RS. The slope of RS, now we could do 4 minus 3 over 2 minus 0, but since it's on a graph, we can just count. Up 1, right 2. Up 1, right 2. And then the slope of OT. Up 1, up 2, right 1, 2, 3, 4. Up 2, right 4, which reduces to 1/2. So since these are parallel, and we can put these little triangles there, we have shown that this is going to be a trapezoid. Because you can clearly see the other two legs are not parallel, they're going to intersect. Now technically we could prove that the other two are not parallel. RO is easy because the slope is just a straight vertical line. And in that case, there is no slope. And the slope of ST is down 1, down 2, right 2. So down 2, right 2, which is -1. So 2 of the sides are parallel and the other 2 are not. That proves it's a trapezoid. Now, to determine if it's isosceles, we need to know the length of RO and ST. Now RO is easy because you can just count. 1, 2, 3. So the measurement of RO equals 3. Now we just have to do the measurement of ST right here. And we have to use the distance formula for that. But we're going to be doing that a lot, so you're going to be used to it. So we're going to do 4 minus 2 squared plus 2 minus 4 squared. Okay? And that's going to give us the square root of 8. Well, 3 squared is 9, so right now we know that it is not isosceles. It is just a regular trapezoid. Because the square root of 8 is not 3. So it is just a trapezoid. Okay? Not isosceles. Okay, some theorems. I will let you read this yourself, all the details. But basically, the idea is each pair of the angles on the base are congruent to each other. Right? And then the converse is, if the base angles are equal, then the sides are parallel. The bases are parallel. Okay? And if it only has one pair of congruent angles, it's an isosceles. Okay? So the first one is if it's isosceles, the base angles are going to be equal. And then on this one, if the trapezoid has one pair of base angles, it's going to be isosceles. And the last one is the diagonals are congruent. Only if it's an isosceles triangle. Sorry, my bad. Isosceles trapezoid. Only if they are congruent can it be isosceles. Alright, example 2. Stone above the arch, St. Louis arch, or this arch, is an isosceles trapezoid. Find K, M, and J. Well, for this situation, we just talked about, if it's an isosceles trapezoid, that means K and L are going to be congruent, and J and M are going to be congruent. Alright? So, right off the bat, we know the measure of angle K is 85 degrees. Now, being that it's quadrilateral, our magic number is 360. Well, 85 times 2 is 170. So if we subtract 170 degrees, that means we have 190 degrees left. And since the other base angles have to be equal, if we divide 190 by 2, that means the measure of angle J is 95 degrees, and the measure of angle M is also going to be 95 degrees. Okay, another theorem, the mid-segment theorem. Okay, the mid-segment of a trapezoid is parallel to each base. Okay, so just another parallel line. The bases are parallel, the mid-segment is parallel. The other interesting thing is it's half of the sum. So in other words, this line right here, this piece, is actually the average of this and this. In other words, you add those up and divide by 2. And that's where this formula comes in. And it can be written like that, or it can be written like this. AB plus CD divided by 2. Multiply by a half and divide by 2 are the same thing. Alright, in the diagram, MN is the mid-segment. Okay? And even if you weren't told that, you know it because those are equal, which means those 2 points are midpoints. Find MN. All we're going to do is add 28 plus 12, so it'll be 12, not 13, and divide by 2. So 28 plus 12 is 40. 40 divided by 2 is 20. So the measure of MN is 20 inches. Alright, find the length of the mid-segment of YZ. Okay, well that means we need the length of SV and TU, which means we need to do distance formula for both. It doesn't take that long, you're going to get very good at this. We're going to be doing it a lot. So 6 minus 2 squared plus 0 minus 2 squared. Well, 6 minus 2 is 4, and 4 squared is 16. 0 minus 2 is negative 2. Remember, that squared is not negative 4, it's positive 4. So this is the square root of 20. Okay? Now, we're going to practice this because it's going to be important in this chapter. Remember, you can use those green cards on your desk when we're in class. We're going to break down 20, if the board would decide to work. We're going to break down 20 into the perfect square 4 and 5. The square root of 4 is 2, so this simplifies to 2 root 5. That's the length of SV. Now we're going to work on the length of TU. And that's going to be 10 minus 2 squared plus 8 minus 12 squared. 10 minus 2 is 8, square root is 64. 8 minus 12 is negative 4, but remember when we square that, it's a positive 16. So that means it's the square root of 80. Now right off the bat, you can tell they're not equal, okay? Which we're not trying to find out, but we know they're not equal to each other, okay? But these are the bases. So we need to simplify this. All right? Now, if you use a chart, 16 times 5 is 80. 16 is a perfect square. That is 4 root 5. That is the length of the other base. So, we have to add our bases and divide by 2. So 4 of these plus 2 of these is 6 of these. And 6 divided by 2 is 3. So 3 root 5 is the measurement of YZ. Final answer. Okay, more theorems. Gotta love geometry. Okay, a kite. A kite is this shape right here. Okay? The diagonals are perpendicular. It means they form a 90-degree angle. They intersect at 90 degrees. Also, if it's a kite, there's one pair of opposite angles that are congruent. So it's like the sideways part of the kite. Not the top and the bottom of the kite, but the other two angles are going to be congruent. Okay? And notice, these pieces are congruent, and these pieces are the same measurement. Okay, so let's look at the kite. We know by the rules of kite that this and this, D and F, are going to be equal to each other. And being it's a quadrilateral, our magic number is 360. So first off, we're going to add 115 plus 73. And we're going to get 188. We're going to do 360 minus 188, and that's going to give me 176. Now, that's between the two angles which are equal, so we need to divide by 2, and that means 86 degrees at each angle D and F. And last but not least, almost done, what is the most specific name for this quadrilateral? Well, the diagonals bisect each other. So that means it is a parallelogram. But can we decide whether it's a rectangle, a rhombus, or a square? No, we cannot. We cannot be more specific because we know nothing about the angles and we know nothing about the sides. So this is the most specific name we can come up with without that extra information.